Okay, so on these problems, we're looking at, they're asking us to classify. They get this example and this example, and they're wanting us to classify. What is a, what's a complex number, a real number, an imaginary number? What are those? What are those categories? Well, let me give you some information on that. You guys know, think with me now, what is the square root of 9? It's 3, yeah. And if a younger child was to ask you why is the square root of 9 3, what would you say? When you say, don't bother me, kid, just do what I say, no stupid questions. No, I'm just joking around. But yeah, why is it? You guys were saying it because 3 times 3 is 9, right? So that's how square roots work, right? Exactly. So with that same thinking, I'll write over here because this is what you guys said. Because 3 times 3 is 9 total. Okay, so then by that same thinking, then what's the square root of negative 3? Change of color here. I'm sorry, of negative 9. What's the square root of negative 9? Could it be negative 3? No, because why? Because negative 3 times negative 3 actually would be positive 9. Uh-oh, so that won't work, right? It won't go back to negative 9, will it? And it can't be plus 3 because plus 3 times plus 3, again, that's positive 9. Huh? Well, I got it. You could do 1 negative and 1 positive, huh? Because negative is positive. But that's not the same thing times itself, is it? Which we all know you're supposed to do for square roots, huh? Which we all just agreed to a second ago when we said, what's the reason, right? So do you see the problem? You can't do it. It's impossible, huh? Well, how about we say it this way? There's no real answer. You can't take the square root of negative 9. You with me? Nothing times itself is negative 9, right? Nothing times itself, right? We're looking for what number times its very self would be negative 9. Well, no number. You'd have to have 1 negative, 1 positive, and that's not the same number times itself. That's the number times its opposite. And that's not what square roots are asking for, huh? So it's impossible. It's not real. You can't do it. True. You can't. It's not real. You can't do it. So, but we'd like to do it anyway. And so what are we going to do? Anybody know? When something's not real, what do? Like when we're kids, we use our imagination. Feels like I'm making it up at this point, huh? But I promise I'm not. Mr. Herring, come on, is this real? Right? Are you telling us math is made up? I hope this isn't news to you, but all of math is made up. Not just these numbers, all numbers, right? You ever seen the number 5 somewhere? You've seen 5 people, 5 cars, 5 objects, but you ever seen actually the number 5? No, you can't. It's just a concept, right? Math is made up. Right? You may say, well, I've seen the number 5. Now, I don't mean the number 5 written somewhere, spray painted on the wall, or 5 people, 5 objects. I just mean 5. What if I said, I was on the way to class this morning. I saw 5. There it was. Not 5 objects, not the number 5 written on the wall somewhere, but just 5. You would know I'm ready for the rubber room, huh? Because you can't see math. Math is not, something real in the real world, but it's made up. I don't know if this is news to you. Class is over. What are we even doing here? Math is made up. I let out the secret. Don't tell the dean. I wasn't supposed to tell anybody. No, I'm half joking, but I'm mostly truthful. Math is made up to describe things that are real. Not only are imaginary numbers, which we're about to use, made up, all the numbers are made up, right? But they are made up to describe things that are real. So if I saw 5 cars in an accident out on the corner of McKinley and Blackstone coming to class this morning, I could come and tell you I saw 5 cars in an accident. You know the concept of 5? I know the concept of 5, so we can communicate about things that are in the real world. So math is made up to describe things that are real, isn't it? That's how it works. So imaginary numbers, this is not the first time we're making things up. So here's what we do. You can't do the square root of negative 9. So you say, well, take that negative and just kick it to the front. That's the problem, right? And put an I there for imaginary. That's literally, I'm not making this up. This is really what we do. So you put an I in the front. The negative is no longer in there. You kick out the I and it puts an I'm sorry, you kick out the negative and it becomes an I in the front because you're saying we can't do the square root of a negative number. It's imaginary. So, okay, so what do we get then? And then that's 3i because the square root of 9 is 3, right? And you can put the 3 in the front or the back. We usually just put the number in the front. You know, I3, 3i, whatever, same thing. So that's 3i. So the square root of negative 9 is 3i. You tracking with me? This isn't hard. It's just a little weird. Let me give you another. What would be the square root of, let's say, negative 4? See if you're getting this. So what do you do when you see a negative? You kick out an I. So it's I square root of 4. And then what's the square root of 4? 2. So it's just 2i. So basically, you just do the square root like the negative's not there. Square root of 4 is 2. Square root of 9 is 3. But the negative is there, so then you just call it I for imaginary because it's not real. It's imaginary. You tracking with me? So when you have a negative in a square root, the answer is going to be imaginary, and then you just do the square root. So what would be the square root of a negative 16? What's that going to be? 4i. Exactly, because the negative kicks out an I, square root of 16 is 4, boom, 4i. 4 imaginary units. So let's stay with questions on mine. If you have questions on yours, I'll do that in a second. Any questions on what I have said or done so far? Yeah.
What if it's a number?
Oh, like the number that's not rootable, like 5 or 6 or 7. Yeah, good question. You just leave it. So, so for example, if you have the square root, good question, square root of negative 5, you take that negative again, you shoot out an I, and then the 5 would just stay in the root because you can't root 5. Right on, exactly. You cannot square root 5. So it would just stay that way. But the I is still in the front now. No more negative inside. Does that make sense? A negative inside kicks out an I. Okay. Now, having said that, we've invented a new thing. We really have. We've invented it called complex numbers. I'm sorry, called imaginary numbers. This is an imaginary. The I that really does stand for imaginary. So it's an imaginary number. Now, what we want to do now is take imaginary numbers and put them together with real numbers to make a brand new thing called a complex number. Are you tracking with me? You hearing what I'm saying? So you can have a number like 7 plus 2i that has a real part and an imaginary part. And the whole thing is what we call a complex number. We call it a complex number for obvious reasons because it's complex, right? It's not simple. It's got both, you know, it's got 2 parts to it, real and imaginary. So that's what a complex number is. It's made out of real part and imaginary part put together. So therefore, you could think of it like this. If you talked about, let me see, how are they doing this? Yeah, real, imaginary, and then complex. Okay, if I talked about the state of California. Here, there's my best drawing of the state of California. It's not so good, but we'll just pretend. We've got California, and we got Fresno kind of in the middle here. And we've got, I don't know, LA, probably further down south, but whatever, down there, right? So, and if I was right here in Fresno, which I am and you are, we're in Fresno. Are we also in California? Well, yeah, you're in Fresno, you're in California, you're also in the United States, you're also in North America, right? So, so that's the kind of thing they're about to ask us about. Not the state, but here's what I'm talking about. If you think about the world of complex numbers, if something is we talk about the complex numbers. Within the complex numbers, we can have, let's talk about, oops, the wrong button there. We can have real numbers. Let me make that bigger. We can have real numbers. And that'd be like 7 or -2 or whatever. And then we can have imaginary numbers. Like 3i, -6i, right? And then we can have numbers out here that are like 4 - 2i, and 6, -6 plus 5i, etc. How are we doing? Am I making any sense? That's just like me saying we got the whole state of California, and then we got Fresno and LA that are part of it. There's other parts of California that are not Fresno and LA, right? You can be in California and not be in Fresno or LA. You with me? You say, I'm up north up here. I'm up in Eureka. We have family that lives up in Eureka. Right? So you can be in other parts of California. All of California is not Fresno and LA, right? So that's what I'm saying. All the complex numbers are not purely real or purely imaginary. Some of them are a combination thereof. Are you tracking with me? So you can be out here, you can be here and say, well, yeah, I'm the number. That's one number, 4 - 2i. I know it's got 2 parts to it, but it is altogether one number. We call that a complex number, 4 - 2i, and -6 plus 5i. Now, there's real numbers that just have a real part and have no imaginary part. And there's imaginary numbers that just have an imaginary part, no real part. And then there's the numbers that have both. You picturing that? All right, so now let's come back up here and say, how about -8i? What is it? Is it a complex, a real, or imaginary? It's imaginary. Now, somebody might say, yeah, I see it's imaginary, but isn't it also complex? Isn't it also, if I said, hey, I live in Fresno, so don't tell me I live in California, what would you say? Well, yeah, if you live in Fresno, you live in California. Well, yeah, if you're an imaginary number, you are also complex. Your real part just happens to be 0. Is that making sense? Am I totally losing it? So yes, the answer is imaginary, but yes, it's also a complex, but that's why they said smallest group. They want you to select the smallest set as part of it. How about the next one? -8 plus 9i? That's a complex number, isn't it? It's not purely real. It's not purely imaginary. It's actually both, isn't it? And so there we go. Question on that one. Question on what I've said?